Have you ever wondered what makes sound possible? How do whispers, music, and the roar of a jet engine travel through the air to our ears? It all comes down to the fascinating world of sound waves and their propagation. Sound waves, in essence, are mechanical waves classified as longitudinal waves. They carry sound to our ears by moving through a certain medium. This could be a solid, liquid, or gas. And the fascinating part? The speed at which sound travels isn't random. It depends on two key factors: the density of the particles in the medium it's traveling through and the temperature of the medium. The denser the medium, the faster sound travels. That's why sound travels fastest through solids. Similarly, the warmer the medium, the faster sound travels. Consider a guitar as an example. When you play the guitar at the neck, the sound is sharp. This is because the shorter the distance, the higher the frequency. The same principle applies to the density and surface area of the strings. The smaller the surface area, the higher the frequency. And when you pluck the strings harder, the sound is louder, which means frequency is directly proportional to force. Moving on, let's explore another example, the organ pipe. This is a sound source that uses a column of air as its vibration source, like flutes, trumpets, or pianos. Organ pipes are divided into open and closed types. Scene script. Sound intensity is another fascinating aspect. It's a measure of how loud a sound is. Intensity is the amount of sound energy that hits a unit area perpendicular to the direction of the sound wave every second. The closer you are to the source of the sound, the louder it seems. This is all about the intensity level of sound, which is the logarithm of the ratio between the sound intensity and the threshold of hearing. Finally, let's touch upon the Doppler effect. This is the change in frequency of a sound wave as perceived by an observer moving relative to its source. For instance, when a sound source is stationary, all listeners hear the same frequency. But when the source moves, one listener hears a higher frequency while the other hears a lower one. In summary, sound waves and their propagation are a complex yet fascinating subject. We've learned about how sound travels through different mediums, the factors that affect its speed, and the role of frequency and intensity in the sounds we hear. We've also touched upon the Doppler effect, which explains the change in frequency when a sound source moves relative to the listener. Sound is all around us, shaping our understanding and perception of the world. It's a constant reminder of the intricate and remarkable physics that govern our daily lives.